in this problem, we need to make sure we're reading the full prompt, because what it says is that the overall test score is determined by throwing out the lowest, sorry, I'm not writing yet, throwing out the lowest test score and then averaging the remaining ones. So if we look at the list of scores for Victor, we can see 5 test scores, the lowest gets thrown out, so the lowest was 62. And now we want to average the remaining ones. So we're only averaging 4 scores, not 5. So 78 plus 83 plus 84 plus 93. That's the total number of points earned on the 4 tests. Now we want to divide by 4 tests taken by the number of data points so that we can figure out on average how many points did Victor earn. And once we do that, you will get, I'm not going to redo the math. The answer here is 84.5. The answer actually is E. If you had averaged all of them together, you would have got 80, but that's incorrect. If you knew to throw out the 62, but you divided by 5 instead of 4, you would have got 67.6, which is also incorrect. So that might explain why you got A or B instead of E. So as far as that goes, here's the answer, and we can move forward. Today we're going to be looking at volume of pyramids and cones. Okay, so this is going to mean we're getting a new volume formula. So before we were working with the volume formula that the volume of a prism is the area of the base times the height. Remember that B represents, the capital B represents the area of a base. Now we're going to be looking at a new volume formula, but let's take a second to derive what this formula is going to be. And to derive this, we're going to need to remember that the volume of a prism is that particular formula. So let's go here. We're going to look at this diagram real quick. And the first thing I want to do is it's taking its time here. Okay, it should work now. So there we go. We're looking at essentially, let's just call it a cube. It could be a rectangular prism. Maybe the dimensions aren't all right. That doesn't actually matter here. But let's just call it a cube to make it straightforward. So if we're looking at this cube, we know that the volume for this is the area of the base times the height. So if we knew the dimensions, we could find the area of this base down here. And then we could multiply by the height and we're done, right? So we're good with that. So what we're going to do is we're going to split this up in a weird way. And you kind of already got to see that at the beginning, but let me go ahead and split this. And how we're splitting this is in a weird way. We're going to split this kind of with a plane cutting through from this side, from this vertex to this vertex to this vertex. It's creating this kind of triangular split in it. And then it's going to be another split from this vertex up here to this one down at the bottom to this one right here. And lastly, we're going to have another split from this vertex to this one up to the top. So all these splits meet up in this top corner. All right, now the reason for doing that will become clear in just a second. And what I'm going to do is I'm going to rotate this out. And when you do that, you can see what's happening. We've actually created 3 solids out of this cube. And so I'll show you this again real quick. We can rotate that out and you end up with what would we call any one of these shapes, any one of these solids? It's a little bit weird looking, but we do have a name for it. Starts with a P. Ends in pyramid. Pyramid. Okay, there we go. These are pyramids, and they might look a little weird to you because they're not the typical pyramids that you think of, like the Egyptian pyramids. But these are pyramids in the sense that if we look at the very bottom, this has a base. And the good thing about the base of a pyramid is that whatever side is on the ground will be the base every single time. But as we move up from the base, notice that this cross section gets a little smaller. If I move up higher, it gets smaller still until I get up to the top. And this cross section is very small. And then, of course, at the very top, it's just a point. So we talked in the past about, we didn't actually perform any, but we have what are called dilations, where a shape gets bigger or smaller. So you can almost imagine this as a three-dimensional dilation. We start at this very small point and we project this image bigger and bigger through space until we get to the biggest possible image of it down at the base of it. All right, so if you want to, if that helps you to think of it, I don't know. But the big point here is that the cross-section is not constant. There is no constant cross-section anywhere in this shape, in the solid. So what we're going to do here is kind of use this diagram to figure out what the volume of this pyramid is going to be. So knowing that this cube has a volume of, with this formula, whatever it happens to be, it's that formula that we follow, how many pyramids, maybe I should add this, these pyramids are all equivalent. And with this red one, let's focus on the red one for a second. This one has, let me change the color so we can see this. This one has the same base as our cube. All right, hopefully you guys can see that. It also has the same height as our cube. So as far as that goes, I could get the area of the base. In fact, I'm going to put a capital B right there. I could get the area of the base, I could get the height, and so far, it's going to be the same formula. But if I multiply that together, I'm really getting the volume of the entire prism right there. I don't want the entire prism, I only want that pyramid. How many of these equivalent pyramids fit in that cube? How many? 3. Yeah, and if this was a regular school year, what I would have done is I have these pyramids and cylinders that have the same base, same height, but one's a cone, one is a cylinder. That's what I was trying to say. And you can see that I can pour 3 pyramids worth into the cone and it works out perfectly. Sorry. 3 cones worth into the cylinder. Okay, I'm getting my notation mixed up. But let's kind of work through this now. So I've got this. This is the volume of a prism. So the volume of a prism is equal to 3 times the volume of the pyramid. So let's just divide. I want to find out what the volume of a prism is. Let's figure out this formula. I'm going to divide by 3. So when I do that, the volume of the pyramid is equal to the volume of the prism divided by 3. And if we're good with that, let me just do one last thing. I already know the volume of a prism is area of the base times the height. So I'm going to erase this, and I'm going to put this. The area of the base times the height divided by 3. There it is. That is our volume formula. So you have 2 to work with. It's either this one if it's a prism, or it's this one if it's a pyramid. And the prism works for cylinders, and this one works for cones. Okay, so does the way that we came up with that formula, does it make sense? In the end, you're not going to be tested on how we came up with it, but I like I said before, I feel like it's important to know why this is a formula, not just me say, here's the formula, move on. So let me go ahead and move back to this. Clear all of my writing. Now I do have the volume formula up here in the top right, but I'm going to go ahead and add this version of it because I imagine some people prefer it that way. So area of the base times the height of the pyramid divided by 3. So it doesn't add much to our previous volume formula. So is this a pyramid that we're looking at in this diagram? Yeah. So we know that we're going to start with this volume formula. Area of the base times the height divided by 3. What shape forms the base of this pyramid? It's a rectangle. So this right here, and the good thing about the pyramids, like I said before, is that the base will always be on the ground. That's not true with prisms, but for pyramids, that will be true. Now, theoretically, I could give you a problem where the base isn't on the ground, but in practice, I don't do that. So just kind of be aware of that. So knowing that, let's get the area of that base. And what is our area formula for a rectangle? Base times height. So when we're talking about the base and the height here, we're talking about a rectangle that's 10 by 8. So what would my base be? 10 times 8. So this part, pretty straightforward. And all your problems today are going to be straightforward. You will have the dimensions known. You just need to go through and figure out how to plug them into the correct formulas and get your answer. But you don't need to worry about doing any trigonometry or special right triangles today. That'll be tomorrow. 10 times 8 is 80. This is inches. So that's inches squared. I'm doing this a little bit fast, but you should be familiar if you've been keeping up with your work. So this shouldn't be too big of an ask. So now what I want to do is take the area of the base and plug it in to that formula right there. And what that gives me is 80. What's the height of my pyramid? 6, yeah. Again, it's pretty straightforward as far as that goes, but you guys can do the math. You can figure out what the volume of this pyramid will be. And there it is. We've seen it 2 different times, and that's good. I like seeing it. So 160 inches cubed. So even though it's a new shape, it's a new formula, I wouldn't say this is really complicating things that much. As long as you know which one to pick, you'll have both these volume formulas available to you. So you'll be able to pick which one is the appropriate one for a given problem. All right. Are there any problems on this? Or any questions on this, rather? All right, everyone's feeling good. Okay. Now we've got this. What is the volume of this triangular pyramid? It go ahead and gives you the name of it. So you should know what the base is, what shape it is. But what's my volume formula? All right, make sure when you're saying that it's the area of the base times the height of the pyramid divided by 3. Because like I've mentioned it many times, but we use base and height a lot. And we need to remember in context what it is that we're referring to. This right here is the height of the pyramid. But let's remember for this particular base, what shape is it, or maybe what formula are we using to solve for the area of the base? There it is, thanks. Base times height divided by 2. What height are we referring to here? There it is. It's the height of the triangle here. We're not going to switch up our notation, but you just need to keep it straight in your own head. And so when we're talking about this, if I draw the base of that triangle, that's what I have. So which of these would be the base of the triangle? Three. Obviously, it doesn't really matter which one we call the base and the height. And because it's the same number, it especially doesn't matter. So the other three will be the height. Remember, the two dimensions have to be perpendicular. These happen to be. The 3 and the 3 have a right angle between them, so we're good to go. You can go ahead and write down what you get for the area of the base. There it is. Good job. So pretty straightforward. I won't plug this in. I want you guys to finish solving for the volume based on what we found for the area of the base. So we have 6 millimeters cubed for the volume here. And just in case anyone was not getting that answer, we took the area of the base, which is 4.5, multiplied it by the height of the pyramid, which is 4, and divided by 3. So you can all receive the answer given there. That's good. All right, let me clear this. We'll look at another example. I think I was going to skip this one. Let's look at this. All right, what I might do is actually let you guys give this one a go on your own, and then we'll walk through the process in a few minutes. But I want everyone to give it a try. If you come up with an answer, feel free to write it maybe in this box right here, what you get as an answer. Multiple people can answer if they want. All right, everyone has had time, I imagine, to work through this. And if you know what you're doing, you will come up with the answer. If you are not sure yet, then let's figure out where you're getting stuck and what we should do. All right, this is a cone. Now this says the volume of a pyramid, but we use the same formula for cones. So the volume of a cone is going to be area of the base times the height divided by 3. If we want to start plugging in, we can do that. We don't know the area of the base yet, which is this circle down here, but we do know that the height of this pyramid, this cone, is going to be 9. So if I can figure out the cone, the area of the base, then I can plug it into this formula and I have my answer. Because it's a circle at the bottom, the area formula is pi times radius squared. You don't have to have these formulas memorized. You do need to know how to find them, and there is a reference sheet available if you want to have that handy. So now we've got pi times, well, what's the radius of this? We know that 8 is the diameter, so I'm just going to take half of that, which is 4. When you multiply this out, you're going to get you're going to get one answer, but you might round it to 50.3, or you might keep it. Let me write this a little differently. Maybe you get 50.3 as your answer because you round. Maybe you record it as 50.26. And there is a benefit sometimes of not rounding until you get to the very end of your problem and kind of keeping a few extra decimal places along the way. Not a big deal, but let's say we use 50.26. So I'm going to plug that in. That, because that was the area of the base, that gets plugged in right there, 50.26. When I multiply this out, 50.26 times 9 divided by 3, I will get 150.8 cubic feet. Now, if you round it at the beginning, in the first step, if you round it out to 50.3, you're going to get 150.9. And is it a big difference between 150.8 and 150.9? No, not really. 150.8 is the more accurate answer. 150.9, you would not lose credit on the test for that. But just, you might, for good mathematical practice, as you're getting into more and more math later, you might want to wait to round until you get to the very end of your problem. But either way works for me for right now. So with that, we've seen how to find the volume of a few different pyramids and cones. Let's look at one more solid. All right, and with this one, let's just look at this. What is our volume formula for this? So what did you think? Are you still looking at it?
Instead of the area of the base times the height of the pyramid.
So maybe we can think of it this way. We have area of the base times the height. Before we kind of determine if that's right or wrong, let me ask this. Are we looking at a pyramid or are we looking at a prism? This is actually, yeah, a prism. And I intentionally put this one in there. When you get to your homework, you're not going to have any trick questions. But for right now, I wanted you to be aware that sometimes it's easy to look at something, at this particular solid, and you're thinking it's going to be a pyramid, so you assume it's a pyramid, and you use the wrong volume formula. But this is a prism because you can see that this cross section right here is the same cross section the entire way through, all the way to the very back. So this, if we were going to draw this with the base on the bottom, it would look more like this. So that is a prism. Now, on the homework tonight, that's not a big deal to determine if it's a pyramid or a prism because they're all going to be pyramids or cones. But on your test, of course, it's going to be a mix of pyramids and prisms in no specific order. So you're going to want to make sure you can kind of look at it and determine before you jump right into solving. All right, we're not going to go through and solve this, but we could find the area of the base and then just multiply it by the height, and we would have our volume. All right, so that's all well and good. So you do have a PDF up in Canvas today, and you can be working on that for the remainder of class. If you have any questions that come up, certainly let me know. I did include the answer key in your PDF today, and that's on purpose, so you guys can double check your own work. If you're checking yourself and you're seeing you're getting everything right, good. You know what you're doing, you're in good shape for the test. If you're not able to get the answers to match up correctly, you're not sure why, that's a great opportunity to ask me for some help. So anyways, if you have questions on any of the previous homework or tonight, feel free to stick around. If you are good to go, you feel like you know what you're doing, have a wonderful day. I will see you tomorrow.
Bye, thank you.
Bye.